So our interaction with new material says, for example 1, about how many times larger is 0.0814 compared to 0.000199. Let's remember that our key point tells us estimation can be used to compare numbers in scientific notation by comparing multipliers and powers of 10. So what should our first step be when we're comparing our two numbers? Our first step should be to write our numbers in scientific notation. I have the value 0.0814 and 0.000199. So let's look at our first value here. If I need to write that in scientific notation, I know I need to have a multiplier that's between 1 and 10. So if I look at my digits, I have 8, 1, and 4. I should put my decimal place in between the 8 and the 1. Now I need to find my power of 10 that I'm multiplying by. So again, looking at my original number, I see that I moved my decimal place 2 times, so I should have 10 to the negative 2 power. Again, looking at our second number, I have the digits 1, 9, and 9. So to have a multiplier between 1 and 10, I should put my decimal place between the 1 and the first 9. If I know that's where I'm going to be placing my decimal point, I need to move it how many spaces? I know I need to move it 4 spaces over, so I have 10 to the negative 4 as my power of 10. Now that I have my numbers in scientific notation, what should my next step be? Second step is going to be to estimate our numbers by rounding our multipliers. So let's look. For my first number, I have 8.14. If I want to round that out to the nearest whole number, am I going to round up or down? I'm going to round down so that it's approximately 8 times 10 to the negative 2 power. For my second value, I have 1.99, and I want to approximate that to the nearest whole number. So I'm going to round up to 2 times 10 to the negative 4. Again, remember that when we're estimating our numbers, we're only estimating our multipliers. We're keeping the magnitude or the power of 10 the same size. We've estimated our numbers. Let's go ahead and move to step 3, which is going to be to compare our multipliers and our powers of 10 through division. So when we're looking through, let's first compare our multipliers. Again, we're looking at our estimated multipliers. So my first value is going to be 8 in comparison to 2. We're dividing so that we can see how many times bigger our first number is in comparison to our second. So I know that 8 divided by 2 is equal to 4. So that means 8 is 4 times larger than 2. Now let's compare our powers of 10. My first power of 10 is 10 to the negative 2, as I can see here. And again, we're going to divide by 10 to the negative 4. Keep in mind that when we have our exponent rules, when we're dividing by a number with the same base, so in this case our base of 10, we're going to subtract our exponents. So I'm going to have negative 2 minus negative 4 as my exponent. That's the same as saying 10 to the negative 2 plus 4, which is equal to 10 to the power of 2. So now that we've compared our multipliers and our powers of 10, we can simplify our comparison and write our complete sentence for our answer. Let's first simplify our comparison. I know that 8 is 4 times bigger than 2, as we found here. I know that in our power of 10, 10 to the negative 2 is 10 to the second power bigger than 10 to the negative 4th. If I wanted to simplify that out, I could say that I have 4 times 100 or 400. That means for my final step, I can say that 0.0814 is 400 times larger than 0.000199. And I have my answer. Now that we've gone through this problem and I've given you guys your steps, why don't you go ahead and try number 2 in your interaction with new material on your own. Example 2 says, about how many times larger is the population of Chicago, which is 3,138,000 people, compared to the suburb of Evanston, which has 61,500 people. So we can tell based on our steps that our first thing that we should be doing is to write our numbers in scientific notation. When we're moving our numbers into scientific notation, I need to make sure that I first pick a multiplier that's between 1 and 10. So for my first value, I'll have 3.138, putting my decimal place in between my 3 and my 1. If I know that's where my decimal place is going to go, I need to move my decimal over how many times to get the proper magnitude of my number. I'll need to move my decimal place over 6 times, which means that I should have 10 to the power of 6 for my magnitude. Our second number, I'll have 6.15, again to get a multiplier between 1 and 10. If that's where my decimal place is going to go, I need to move my decimal place over how many times? I need to move my decimal place over 4 times so that I'll have 10 to the power of 4. And now I've written my numbers in scientific notation. Step 2, which is going to be to estimate our numbers by rounding our multipliers. So again, I have for my first number 3.138, and I want to round that to a whole number, which means I should round down so that I just have 3 times 10 to the 6th. For my second number, I have 6.15, and again, I want to round those numbers, and I'll round down to 6 times 10 to the 4th. It's step 3, which is going to be to compare our multipliers and powers of 10 through division. So again, my multipliers are 3 and 6, so I'm going to divide my first multiplier 3 by my second multiplier, which is 6. 3 divided by 6 is the same as 1/2. So I know that 3 is 1/2 of 6. For my multipliers, I have 10 to the power of 6 divided by my second power of 10, which is 10 to the 4th. Again, using my exponent rules, I know that I'll have 10 to the 6 minus 4th power, which is the same as 10 squared. I've compared my multipliers and powers of 10. I can move to my final step, which is to simplify my comparison and write a complete sentence. So let's look at my comparisons. I know that my multipliers, when compared, gave me 1/2 because 3 is 1/2 of 6. I know that when I compare my powers of 10, I found that 10 to the 6th is 10 to the 2 times bigger than 10 to the 4th. Same as saying 1/2 times 100, and I know that half of 100 is 50. this value of my comparison is going to be the comparison that I have between my two numbers. So I know that this is what we're going to be going through today. Again, remember that estimation can be used to compare numbers in scientific notation by comparing multipliers in powers of 10. Take the steps that we've gone through and use them to complete your independent practice in your exit ticket on Google Classroom.